Hi, this is Ms. Hammonds. This presentation is for Bio 2113 AP1, Chapter 5, the Integumentary System. If you hear a little bit of noise in the background, I apologize. It's hard to find a quiet space. So make sure that you have your Chapter 5 lecture handout notes available to you to support you through this presentation. So the first thing we're going to look at is the integument. It is an enveloping layer around an organism. Specifically for us, it is our skin. It can be a membrane or a husk. Again, it is part or over the part of organisms, or it can be one part itself as it is for us as the skin. Some facts about the integument is that the skin is the largest organ on the human body. The total area of the average human skin is 1.5 to 2 square meters. The skin is approximately 16% of your total body's weight. Your fingernails grow about 0.1 millimeter per day. That's about 3 times faster than your toenails grow. About 1,000 species of bacteria call your skin home, and your skin renews itself every 28 days or so. There are approximately 19 million cells in every square inch of skin. So moving on, we're going to look at some features or components of the integumentary system. It consists of the skin and the skin's derivatives. Some of these derivatives include sweat glands, sebaceous glands, hair, and nails. Please make sure that you make note of those derivatives, or what's another term that I can use for derivatives? It'll come to me, but like supplemental parts, additional parts of the skin. So the skin is composed of 2 distinct layers. Those layers are the epidermis, which is composed primarily of epithelial cells, and the dermis, that is composed of a dense irregular connective tissue, and in some cases an areolar connective tissue. As you look here, you see we have the outer layer, which is the epidermis, the inner layer, which is the dermis, and then the subcutaneous layer, which is composed of the connective tissue. Let me go back to that image. So if you look at your slide, and I'm thinking, looking at your guided notes, the epidermis is the superficial region that is composed of epithelial tissues. I did mention that. The dermis underlies the epidermis, mostly of fibrous connective tissue. What I did not discuss was the hypodermis, also referred to as the subcutaneous layer. That is a superficial fascia. It's located deep to the dermis layer. It's composed mainly of adipose tissue, and that adipose tissue provides an shock absorption or insulation in that area. The subcutaneous layer also anchors the skin to the underlying structure, which is mostly muscle. All right, some characteristics of skin is that the dermis is very vascularized, while the epidermis is avascular. So the nutrients to the epidermis layer diffuse from the connective tissue located beneath the dermis into the epidermis. And we did discuss the third region located underneath the dermis, which is the hypodermis, also referred to as the subcutaneous layer, consists mostly of adipose tissue. Again, the subcutaneous layer or the hypodermis is not considered part of the skin, but it does anchor the skin to the underlying structures, mostly muscle. So here we have the epidermis. The epidermis is a keratinized, stratified squamous epithelium consisting of 4 distinct cell types, and then 4 or 5 distinct layers. So when we first discussed epithelial tissues in chapter 4, we talked about how those different types of tissues are named and the information that's provided from that name. So looking at stratified squamous, we know that this particular epithelial tissue has more than one layer. And squamous tells us that they are flat. And you can actually see that present here in the skin tissue from this slide. The skin will have 4 or 5 distinct layers depending on the location of that skin on the body. So here we're looking in more detail about the layers of the epidermis. A mnemonic that I use frequently is cute ladies get smart boys. That mnemonic is for thick skin. So it identifies the 5 layers of skin. The one that would not be present in the thin skin is here, the stratum lucidum or lucidium, tomato. Okay, so the stratum corneum is the most superficial layer. It is both present on thin and thick skin. It consists of about 25 to 30 rows of dead skin cells. It's completely filled with keratin. These cells are frequently shed and replaced from the deeper strata, and it serves as an effective barrier against light, heat, bacteria, and other chemicals. The lucidium, which is only present in thick skin, is usually only present, or is definitely only present in the palms of our hands and the soles of our feet. It contains intermediate substances that help support thicker skin masses. Stratum granulosum is a precursor to keratin, so you'll have the development of some keratin or keratinohyaline cells present there. Stratum spinosum is a little deeper. It contains joints between the lower and the upper layers. And the stratum basal is capable of cell division, so it's the most mitotic portion. Remember when we were looking at stratum corneum and it says it is replaced by the deeper strata? The deeper strata that it was referring to is the basal strata. Produces melanocytes and keratinocytes, and all of these cells are pushed upward toward the surface to become part of the superficial layer. So let's briefly discuss some of the types of cells that are present in skin. Keratinocytes produce keratin, and keratin is a fibrous protein that gives skin its protective properties. Melanocytes are located within the epithelial cells, and they synthesize our pigment. So the more melanocytes that are present, the deeper our pigment or the deeper our complexion would be. As melanin is made, it accumulates in the melanosomes, and then that accounts for the amount of keratinocytes in a particular portion of your skin. And it usually is prevalent on the areas of your skin that are facing the sun. So the more sunlight that you are exposed to, the more melanocytes that will be present. I know some of you all tan. I got a forever tan. But for those of you who are wanting to tan your skin and to do it safely, there are some synthetic methods that you could use to increase the amount of melanocytes present in your skin. Some additional cells are dendritic cells. So dendritic cells ingest foreign substances, and they also aid in activating our immune system. Tactile cells may also be referred to as Merkel cells. They are present at the epidermal and dermal junction. Each of these tactile cells combines with a disc-like nerve ending, and they function as sensory receptors. Moving on to the dermis, which is just beneath the epidermis or the epidermal layer. The dermis is made up of primarily connective tissue proper. The presence of fibroblasts and macrophages are there. You may also have some mast cells and some white blood cells. It is rich in its supply of nerves and blood vessels. It also has the presence of lymphatic vessels. All of these will provide nutrients to the avascular epidermis through diffusion. Derivatives of the epidermis are sweat glands, oil glands, and hair follicles. The dermis has two distinct layers, the papillary layer and the reticular layer that we will look at individually. So on this diagram, you see the layers of the skin. Here, closer to and just below the epidermal layer is the papillary layer. Again, it has the presence of the dermal papillae, which are these curves. And then the lower portion, the larger lower portion of the dermis is the reticular layer. So we'll look at some characteristics of each in the next few slides. The papillary layer is the thin superficial layer of the dermis. It is made up of areolar connective tissue. It does contain small blood vessels that allow the diffusion of nutrients to the epidermis above. The dermal papillae that I mentioned a moment ago are peg-like projections from the surface of the papillary layer. They indent in the overlying epidermis and contain capillary loops, free nerve endings, and touch receptors that we refer to as tactile or Meissner's corpuscles. In thick skin, the dermal papillae lie on the top of the dermal ridges, which form the epidermal ridges. Together, these ridges provide fiction that create our fingerprints. Next, we're looking at the reticular layer. The reticular layer is deeper than the papillary layer, and the reticular layer contains dense irregular connective tissue, and this layer accounts for about 80% of the dermis. Okay, some more characteristics about the reticular layer. As I mentioned, it accounts for 80% of the dermis. The reticular layer is denser than the papillary dermis, and it strengthens the skin by providing structure and elasticity. It also supports other components of the skin, such as hair follicles, sweat glands, and sebaceous glands. So when you look at a diagram, let me go back, of the dermis, you'll see some of the derivatives that we discussed. For example, here we have in our subcutaneous layer or the hypodermis, these are our adipocytes or adipose tissue. We have some of our Meissner's corpuscles, some other tactile receptors. We also have some of the blood vessels and capillaries present in the reticular layer. So let's move on. Skin color. There are three primary pigments associated with skin color. We're going to look and identify the three types below. So melanin, all humans have relatively the same number of melanocytes, but in skin, it reflects the amount of melanocytes that may be made or retained in the skin. Keratin is a yellow to orange pigment found in certain plant products such as carrots, but it does also accumulate in the stratum corneum and the fat of the hypodermis. It's primarily present in the soles of our feet and the palms of our hands, hence the coloring. Again, the stratum corneum is the area where, or is going to be found in areas where we have thick skin. Again, the palms of our hands and the soles of our feet. Hemoglobin gives the pinkish hue of fair-skinned people, which comes from oxygenated blood in our dermal capillaries. So looking again at the appendages, that's what I couldn't remember, appendages or derivatives of skin. So we already talked about hair, nails, hair follicles. What we left off were sweat glands and sebaceous glands. And sebaceous glands may also be referred to as oil glands. There are three layers of the hair follicle. The hair follicle's function is to sense insects on the skin before they can bite or sting. Hair follicles guard against physical trauma. They provide support with heat and sunlight protection. The hair of our eyelashes shield our eyes, and the hair in our nose filter large particles away from the air that we inhale. So again, talking about hair and hair follicles. Hair or papilla are flexible strands produced by hair follicles and consist largely of dead keratinized cells. It contains hard keratin as opposed to soft keratin located in the skin. The hair consists of primary two parts, that is the shaft and the root. The shaft are where keratinization, occurs and is completed, but in the root, the keratinization process is ongoing. Here, as we look at the hair and hair follicle, we see a lot of the different structures that are located there. Here are the three layers that make up hair follicles. They are the medulla, the cortex, and the cuticle. The medulla is the innermost layer of the hair shaft. It's nearly invisible and is the most soft and fragile. It serves as the marrow of the hair. The cortex of the hair is located between the hair cuticle and the medulla. It is the thickest layer of the hair. It also contains hair's pigment, so giving the hair its natural color, or it's the area that is adjusted if hair color is changed. The pigment in the cortex is usually melanin, and it is also found in our skin. Finally, the cuticle. The hair cuticle is the outermost part of the hair shaft. It is formed by dead skin cells that are overlap the previous layers we discussed, and they form a strengthening protective layer around the hair shaft. And then this is just another view showing you the location of all of those structures. So looking again at some appendages or derivatives located in skin, we identified sweat glands. Sweat glands may also be referred to as sudoriferous glands. They cover the entire skin surface except for the nipples and the genitalia. There are two types of sweat glands. They are your eccrine, also referred to as merocrine glands, and the apocrine glands. Both contain a myoepithelial cell, which is a specialized cell that contracts, that contracts by the nervous system stimulation to expel sweat onto the skin. So let's look at the eccrine or merocrine glands. They are located all over the body. They are heavily present in palms and soles of our feet and on our forehead. Hence, where we, if we're nervous or we are hot, we will begin to sweat. Eccrine sweat glands are simple, coiled, or tubular. Eccrine glands release their fluids by exocytosis onto the surface of the skin. The sweat is composed of 99% water with the addition of salts, vitamin C, antibodies produced by the body, dermicin, metabolic waste, like uric acid, urea, and ammonia. And then sweat is controlled by our sympathetic nervous division. It's autonomic, to keep the body's temperature from exceeding what is needed for homeostasis. Sorry, my four-legged visitor just popped in on me, and I don't want to start over. So let's move on. Apocrine sweat glands. Glands that are confined to the axillary or anogenital areas. So when we talked about eccrine glands, we said they're located everywhere on the body except on your nipples. Where else did I say? And your genitalia. That's because the apocrine glands are located there. They are another type of merocrine gland in that they secrete a product onto their hair follicles. But the products that are produced by these are similar to sweat, but they have fatty substances and proteins that are also added. Usually it is odorless, but in a situation where the body may come in contact with bacteria or bacteria is growing in that particular area, an odor can develop. It does come in contact with the bacteria located on the skin, and as I mentioned, it can create a body odor. Apocrine glands don't function until the organism has reached puberty. It will be controlled by the influence of male sex hormones, which we refer to as androgens. They do not contribute to the temperature regulation or stimulate during pain or stress. Let me just go back. So the androgens, the sex hormones, are present both in males and females. Men just have a larger amount of testosterone in addition to these androgens. So here we're looking at a visual comparison of apocrine glands versus merocrine or sweat glands. Here we have apocrine glands, can't even get it out. So if you look at the structure of the cells, these are also located in the epithelial tissue, and you can see that there's a single layer, that they have a columned shape. So this would be one layer. They're not necessarily flat, but it would be simple columnar if we were to describe the type of cells that are present here. Here, when we look at our merocrine glands, you notice that they have definitely more nuclei present because there's a increase in the number of the cells that are present. So this would be a stratified columnar type of epithelial gland or tissue. So continuing on, what are some other glands that are associated with skin? Well, the other glands are the ceruminous glands. They are a type of modified apocrine gland that is found in the external ear canal, and it secretes ceruminin, which we refer to as earwax. Mammary glands are another type of specialized sweat gland located in the breast of females, and it secretes milk. So sebaceous glands or oil glands are simple branched alveolar glands that are found all over the body, again, except in our palms of our hands and the soles of our feet. The secretion is an oily substance that we refer to as sebum. Functionally, sebaceous glands are holocrine or holocrine glands that secrete their products when glands become engorged, then burst, and the liquid and the cell fragments constitute the oil composition. Most oil glands are part of hair follicles and and the contraction of the erector pili muscle forces the oil out of the follicle's base. Sebum works to soften the skin. It also helps soften hair, and for both, it provides a slowing of water loss. It also contains bactericide as well, and it's inactive in children. Hormones stimulate the production of our oil glands at the combination or once we've reached puberty. So here again, we're looking at the structures of some of the sebaceous. So this is a hair follicle, and the sebaceous gland is located on the side of it. And then here again are eccrine glands that are just located throughout the epidermis. So here are some functions of the integumentary system. It provides protection, body temperature regulation, aids in metabolic functions, blood reservoir, and excretions. As we look at protection, we're going to look at 3 skin barriers that aid in the protection of our bodies. First, we have the chemical barrier. On your guided notes, it begins with the physical barrier. If you'll just skip over to your next page so that you can see the chemical information. Chemical barriers include skin secretions and melanin. The acidic nature of the secretions of the skin create an acidic mantle, which slows the multiplication of bacteria present on the skin. And then the melanin also provides protection for UV. The next barrier is the physical barrier. The skin is a stratified epithelium, and the epidermis provides a brick and mortar setup. Along with keratin, it keeps things out of the internal portion of the body. It also contains glycolipids that give the skin its waterproof quality. Finally, our third layer is the biological layer. So this layer includes dendritic cells located in the epidermis, macrophages, and DNA. Dendritic cells again activate our immune system to help fight off any invasions of bacteria or viruses. Dermal macrophages also support in that process. And then DNA absorbs UV radiation and then dissipates it throughout our body. Skin also works to help regulate our body temperature. So the skin secretes sweat to maintain the body temperature at its homeostatic state. Blood is shunted from the skin when temperature goes up and is shunted when the core to the core when the temperature goes down. So blood flow is regulated by our body temperature. The cutaneous sensation. The skin contains many cutaneous sensory receptors. In later chapters, we'll look at more detail of how they function. They alert the body that things like touch and pressure have occurred. Metabolic functions of the skin is that it creates a modified cholesterol molecule that is a precursor for vitamin D production. It's stimulated by sunlight and it makes some proteins, but it also activates some steroid hormones and other functions within the body. Blood reservoir for skin is that it holds about 5% of the body's entire blood volume. The skin vessels can constrict and dilate, shunting the blood in and out of the body as needed. So excretions. So the body will eliminate waste in sweat. And we mentioned uric acid, urea, and ammonia. All of these products are broken down from metabolic processes. The uric acid is a product, again, of a metabolic breakdown. Purines from some of the from the foods that we eat are broken down in our kidneys. They are very critical for ions being regulated in our urine. Some of the foods that we eat where uric acid can come from would be anchovies, dried beans, beer, and peas. Urea is a colorless product, also from a metabolic breakdown. It's a waste product. Particularly, it's a waste product from proteins. And then ammonia is naturally produced in our body. Its formula is NH3. It's, again, another metabolic process that's composed of nitrogen and hydrogen. Next, we're going to look at some types of skin cancer. And I'm not going to go into a whole lot of detail just to identify them. So you have basal carcinoma, squamous carcinoma, and melanoma. Basal carcinoma is the least malignant. It's usually present only in the location of the skin where it's located. Excuse me, sorry. Squamous carcinoma is moderately malignant if not caught soon. It is possible for those cancerous cells to move and migrate to other areas of the body. And then melanoma is the most dangerous and most malignant type of skin cancer. The single most important risk factor for skin cancer is an overexposure to UV radiation and sunlight. Please make notation, put a star beside that. That is information that you need to remember and be familiar with. And then finally, as we finish our presentation, we're going to look at burns that occur on skin tissue. So a burn is a tissue damage inflicted by intense heat, electricity, radiation, or certain chemicals, all of which denature or break down cell proteins and can kill the cells of the affected area. The immediate threat to life resulting from severe burns can be catastrophic loss of body fluids that contain our proteins and electrolytes. Please make a notation of the importance of the immediate threat to life. Put a star by it, underline it. Again, that is severe burns that have a catastrophic loss of body fluid containing proteins and electrolytes. This catastrophic loss can lead to dehydration and electrolyte imbalance, renal failure, and finally circulatory shock. There are 3 types of burns: first degree, second degree, and third degree. First degree burns are only damage to the epidermis. Second degree burns, the injuries exceed the epidermis and usually go to the papillary region of the dermis or the upper region of the dermis. These burns will produce blisters. And then our third degree burns are damage to the full thickness involving the entire epidermis and dermis layers. After the initial threat of dehydration is under control, the next danger to a third degree burn is infection. So very poorly in this diagram, you have what would be classified as first degree burn, which is typically a burn to your epidermis. Typically, if you touch something hot, you get a burning sensation, possible blistering. If it's more severe, or swelling. Excuse me. So in a first degree burn, again, it's the outer layer of the skin. There is pain, redness, and swelling. In a second degree burn, there is partial damage to the thickness. Burns affect both the outer and underlying layer of skin. They also cause pain, redness, swelling, and blistering. And that was my mistake. Blistering only occurs in second degree burns. I've had those too. Third degree burns is the full thickness of the skin, both the epidermis and the dermis layers. They cause a white or blackening char that may appear to the skin. There's numbing, catastrophic fluid loss, proteins, and electrolytes. All right, so this concludes our presentation. I hope that you find this information helpful as you prepare for exam 2. And also refer to these notes as you're working on your exam overview. Thank you for your time and enjoy your evening.